So let's take as an example half sum. And I want to show you something interesting about half sum. So half sum, let's consider the set S is 1, 1, 3, 5, 7, 9. So the sum here is 26. Okay. So half sum would ask, is there a subset which sums to 13? So if I take the subset A, which is equal to 1, 3, 9, so that's a subset, and the sum is 13. So this is the sum of S, and the sum of A is equal to 13. So half sum in this instance of the problem is true. So there is a subset whose sum is half of the total sum. Okay. Now, for the general instance where I feed you this set as input, can we come up with an algorithm to answer the question correctly? And, if the answer is yes, then can we produce this set A? We don't know. We don't have a polynomial algorithm to do that. Now, you might think, wow, this is such an easy problem. Well, go for it. You think it's an easy problem? Go for it. Try to come up with a polynomial algorithm to solve half sum in the general case. If you do, not only will you be famous, you will also be rich. There's $1 million riding on that. And that has to do with what I'm about to discuss. It's not this meager $100 that I was offering. It's $1 million if you could solve matching subsets in the general case. I was just asking for a special solution to the 100 numbers that I posted. But if you can solve matching subsets in the general case, famous, Turing Award, $1 million. Okay, now what's interesting about this problem? So what's interesting about this problem is I don't know how to solve the problem, but let's say you solved the problem and you came to me and said, the answer is yes. Okay, and I say, what? I don't believe you. Prove it to me. So prove it to me. Prove to me the answer is yes. And so you come and you say, my proof is the set A. Okay, and I look at this proof and I say, okay, let me check your proof. So I add up all the elements in A. That's the sum of all the elements in A is 13. So I add up all the elements in A. The sum is 13. And then I go and add up all the elements in S, and it's 26. And I check that 13 is half of 26. And I say, okay, yes, you're right. Your proof works. Okay. Now, what's interesting here? What's interesting here is that I don't know how to solve the problem efficiently. You solved the problem somehow, and then you came up with the proof, i.e. the set A. And what was interesting here is that it was easy for me to check the proof. Easy means I can do it quickly. How long did it take me? If the set S has n elements, then I compute this sum is n, and I compute this sum, which is at most n elements, or at most n, so at most 2n operations, or at most 2n additions. So it took me order of n time to check the solution. So if you find the solution and a proof, then it's easy, i.e. polynomial time. So it's easy, i.e. in polynomial time, it's easy for me to check the proof. Sometimes we say that you are the prover and I'm the verifier, or not sometimes, I'm typically called the verifier. Okay, and the proof you gave me, this subset A, this proof is sometimes called the certificate, the proof. Okay, but the basic idea is you gave me a proof and it was easy for me to check the proof. Okay, and all of these problems are in that flavor that, we don't know how to solve them quickly, but if someone solved it quickly and gave me the proof, for example, like the subset A, or if someone solved the problem, I asked, is there a clique of size 55 in this graph, in this Facebook network? So you come to me and say, yes, and my proof is a set of 55 nodes. It's easy for me to go and check if all of those nodes are friends with each other. So it's easy to check the proofs for all of these problems. And that's interesting. We don't know how to solve them, but if someone solved it and gave me the proof, it's very easy for me to check the proof. Okay? So let's summarize that. It's easy to check the proof. Okay? And it turns out that all the problems in this region that we are fuzzy about satisfy this condition. And so we've given this condition a name. Okay. We call all these problems that satisfy this condition, where if you find the solution and find a proof, then I can quickly check the proof. We call those problems NP problems. So we call that set of problems NP. And you might say, what? What does that mean? So I'll tell you what it means. It stands for non-deterministic polynomial. Okay. And this is a very technical name. It amounts to the statement that for these problems, if you solve them and give me the proof, I can check the proof quickly.